Hey everyone, so today we're going to talk about the continuous probability distributions and puppies, of course. So make sure you review what a continuous variable is and what the other probability distributions are, both continuous and discrete. The one that we're going to talk about for this example is the normal probability distribution. And it's a type of continuous probability distribution that's quite popular. So it operates under the idea that most of the values within a continuous variable fall around the mean. So say we had weights, so puppy weights, since we're talking about puppies, and we say that the weight of a puppy is around 15 pounds. That would be for the entire population of puppies everywhere. And for the normal distribution plot, the further you get away from the mean value, the less probability there is of seeing a puppy or any of the variables, a puppy weight that is extremely above or extremely below the mean. So you're not going to likely see a puppy that is 100 pounds, or you're not going to likely see a puppy that is 1 pound. So the probability of finding a puppy that is far away from the mean becomes less and less the more you go away from the mean. Usually, it's quite difficult to model the distribution of an entire population. So most people will take a sample of that population. So let's say I took a sample of 70 puppies and documented their weights. So we'll say n equals 70, and after documenting their weights, I found out that the mean weight is actually 18, and then the standard deviation is 3. So now, assuming that this sample is representative of the population, I can plot this on a continuous probability distribution plot, this normal distribution plot here. So 18 would be my mean, and then one standard deviation away would be 21, and then if we go to the left, it would be 15. This is one standard deviation, and so we're going over 3 pounds to the left or to the right. And we can continue to fill this in with 24, 27, and then here would be 12 and 9. Now let's try to turn this into the standardized normal distribution. So I just created a copy of what I just wrote, and this is what you would represent the weights using. We can convert this to a standardized normal distribution by turning the mean into 0 and then showing the standard deviations instead of the actual x values. So this would be the x value and this would be the z value. These represent the same thing. It's taking this sample of 70 puppies and plotting it on a normal distribution plot under the idea that the mean value has the highest probability or the highest number of puppies, and when you get to the tails, you have a lesser probability of seeing that puppy weight. And this conversion that I just did from x values to z values can be done on any individual x value using these two formulas. So this is how you go from x to z, and this is how you go from z to x. And remember, x represents the actual continuous variable, while z represents the standardized normal distribution value. And right here, you'll see that this plot is the empirical rule. So it's saying that once you have a standardized normal distribution for your sample or population, about 68% fall within one standard deviation, about 95% of the group falls within 2 standard deviations, and then about 99.7% of the group falls within 3 standard deviations. Now that we have our sample of 70 puppies, and we know their mean and standard deviation of weight, we can now answer the question of what is the probability that the weight of a new random puppy is above 22 pounds. So this would look something like this, and we're going to plot the 22 right around here, so a little bit above 21. And we want to find the area underneath this part of the curve. That's going to tell us the probability that the puppy weights are above 22 pounds. So the area underneath the curve correlates to probability because this axis right here is probability. So our first step to solving this problem is to find this x value z-score. So our x value is 22, and that's not to be mistaken with mu of 18, which I actually just changed here to the simple mu, which is mean. And we're going to use the formula z equals x minus mu over standard deviation. And I'll change the color here to fill in the values. So 22 minus 18 over 3, which will be 4 over 3, and your z value equals 1.33. And this makes sense because it is a little bit above 21, and we know that the z-score of 21 is 1 because it's just one standard deviation away from 18. With this z-score, we can take a look at page 641 in our textbook and first look for 1.3 and then go over to 0.03, and that represents 1.33, our z-score, and that is 0.9082. Let's write that down. 0.9082. What exactly does that mean? That means that 90.82% of puppy weights fall below this value. Or in other words, there is a 90.82% probability of finding a puppy with a weight below 22. And that's shown right here. Now, we're looking for the probability of finding a puppy above 22 pounds. So there's a simple fix for this. We do 1 minus 0.9082, and that will give you the probability to the right of the curve, or above the x value. Because on the z table, if you'll see, it always gives you the value to the left. And that's shown here. It gives you the value to the left of the x. So now, when we do 1 minus 0.9082, we get 0.0918. And this value is telling you that about 9%, we'll say 9.18% of dogs or dog weights fall above 22 pounds. It answers our question also. It's saying that 9.18 is the probability that the weight of a new random puppy is above 22 pounds. All right, let's do one more example using these puppy weights and the same distribution we have. So what is the probability that they would weigh between 14 and 21 pounds? So if you remember our distribution, 21 is one standard deviation away. So we already have the z-score for 21. We just have to find the z-score for 14. So we'll use our formula. X minus mu over standard deviation equals our z-score. So 14 minus 18 over 3. And now we have negative 4 over 3, which is the same thing as negative 1.33. We can again find this value, which I wrote here on the z table, and I highlighted that as the third column and the row that represents negative 1.3. This is page 640. And this is showing the probability that you'll find a puppy weight below 14. And interestingly enough, it is the same probability of finding a puppy weight above 22, because on this distribution, 14 and 22 have the same z-score, except one is negative and one is positive. Because this distribution is always symmetrical, there's going to be the same probability of finding a puppy weight below 14 and above 22. That's always the case with a normal distribution, and that's what makes it really special. But let's go back to the question. Now that we have our two z values, the way you find the area between two values is by finding the area to the left of the larger value minus the area to the left of the smaller value. So we're essentially subtracting this from this in order to get this. So we know the z-score of 21 is 1. I used my z-table to find that the probability of the finding a value to the left of this z-score is 84.13, and then we also know that this probability is 0.10918, so we subtract it and we get 74.95%. So the answer to this question is that the probability that a random puppy would weigh between 14 and 21 pounds is about 74.95%. And that's how we successfully navigate a normal probability distribution.